In this episode, we are going to learn about how to pass an entire array to a function. So in the previous episode, we already learned about how to pass each element of an array to a function. It is possible to pass an entire array to a function using pointer arithmetic. So here in this example, in this program, here I already declare an array that contains 4 elements. So here I am going to pass this entire array to a function. So for that, here I am going to declare a function void display. Function name is display. For passing an entire array to a function, you have to pass the address of the first element in that array to that function. So by using that first element location, we can access the next elements of that array using pointer incrementation. Okay, so here I am going to call that function display. The first argument is the first memory address of the array. So for passing the memory address of the array, we have to use the address operator. So the first element is in n of 0th position, so I have to use that position n of 0. This is the first element memory location of this array. So for displaying this array, we have to pass the size of the array. So here the size of the array is 4 because this array contains 4 elements. Okay, so I pass 2 arguments to the function. First one is the memory location of the first element in that array, and second one is the size of the array. So for receiving these 2 values, here we need 2 arguments. First one is a pointer because the first argument is an address, and second one is a normal integer value. So this is an integer pointer because the values are integers. So integer int star p. So the pointer p will get the address of the first memory location, and for getting the integer, I declare another argument here called a count. Okay, so p will get the pointer p will get the first element's memory location, and the size of the array is now available in variable count. So here I am going to display the array. For that, I declare another variable here and start a for loop. Initialize the variable from 0 and put a condition I less than or equal to count, and increment that value I plus plus, and open the loop body. Okay, now we have to display the function, display the array elements. For that, I use a printf statement, printf. So here I am going to display the first element. So for displaying the first element, put here the values are integers, so %d. For displaying a value present in the pointer, we have to use the star notation and use the pointer name. So this will display the value present in that address. So p is a pointer that holds the memory location of the first element of the array. So this will print the first element in that array. Okay, so here when this loop execute at the first statement, we will get the first value present in that array. It will display value 34. Okay, so now here I am going to add a statement like this p plus plus. What really happens if this statement execute p plus plus? That means increment the value of p by 1. Actually, p is not an integer variable, p is a pointer. That means p plus plus means it will relocate the pointer to the next memory location. That means the pointer now locate to the second value present in that array. So after incrementing the pointer, again the loop execute. So when we print star p, it will print the second element in that array. Again p plus plus means the pointer points to the next memory location. This will continues until the last element prints. Okay, so we can check. So I save the program, compile the program, Okay, there is no need of this return type. Remove the return type, save the program, compile it again. Okay, compilation is success. Now we can run the program. Yeah, here we got the output. We got the value 34, 45, 45, 67, and something. There is last element. Yeah, here there is a mistake in this. Actually, it contain only 4 elements. So here we print 5 elements. That will print the garbage value present in that last element. So we have to change the condition. Here 2 elements are repeated. I change it into 43. Okay, so again I run the program. First compile the program. Now run it again. Now we got the correct output: 34 first element, 43 second element, 45 and 67. This is how we pass an entire array to a function. So you can access all the elements in that array by incrementing the pointer. Okay, so here another interesting thing. Actually, why at the time of calling the function we pass the address of the first element of the array and the size of the array. So instead of passing the first address, I just pass like this. I just mention the array name. So what will happens here? We can check it out, compile it. Here also there is no error, but actually at the formal arguments, here the first argument is a pointer, but here we pass the array name as the first argument. But in the function declaration, the first argument is actually a pointer. But while we compile this program, there is no error. So we can run the program. I run the program. Again we got the same output. How this is happened? So if you pass just the name of the array, actually it will pass the memory location of the first element. So that is another interesting thing. There is no need to pass the memory location of the first element present in that array. If it is an array, if you just mention the array name, that will indicate the memory location of the first element present in that array. Actually this is a pointer. If you just pass the name of the array, actually this will represent a pointer that will point to the first element in that array. So there is no need to pass the first element address of the array. Okay, this is how we pass an entire array to a function using pointer arithmetic.